getting started, and also special thanks to AECOM. AECOM is one of the largest civil and environmental infrastructure design firms in the world. And so we're really pleased that they're able to sponsor the event and Jonathan's able to speak. So Jonathan Pressdee is a vice president and market sector leader for AECOM's drinking water and water reuse business. He's got a chemical engineering and a biochemical engineering background. He's been involved in introducing advanced water treatment technology focused on emerging contaminants, which is kind of a buzzword in our industry, but I think Jonathan will cover that, and also pathogens. His research was used for the basis of standards related to cryptosporidium, which caused some deaths in the Milwaukee area a few years back. He's also been involved in water projects for industrial water users and involved in a lot of direct potable reuse projects where you take wastewater and make it drinking water. He's kind of a world traveler. He's got projects on his resume in the UK, and Singapore, and Chile, and Australia, and Northern Europe, I guess various countries in Northern Europe. Kind of coy about that. And then he's been involved in the delivery of large water infrastructure projects using what the engineers call design, bid, build format of delivery, and also design, build, operate, and finance methods. So please welcome Jonathan and I guess you can go ahead and give your speech or your talk now, and then we'll do the other introductions kind of as we go. Please welcome Jonathan.
Well, good evening, everyone. Thank you, Michael, for the introduction. It's a pleasure to be here on behalf of AECOM and give my overview on the water situation from the world, and then we'll drill down into the national and then Texas and local region for you. We live at an incredible juncture in the history of water management. We are facing new water supply challenges, a growing world that is more globally connected than ever, and dramatic variations in climate and precipitation patterns. Some of the world's driest regions are growing the most rapidly and often face deep, prolonged droughts with periods of intense flooding, events that take place almost simultaneously. Because of this, our traditional thinking about water management is changing rapidly. Throughout history, nearly every major urban area from ancient Rome and Athens to Jeddah, Hong Kong, Singapore, and Los Angeles has required policies, planning, engineering, construction, and operations of its major infrastructure to be dedicated to bringing water to the people. As the world population grows, we are facing a population growth of up to 9 million people within the next generation, 400 million people here in the United States by 2040 is the latest projections I've heard. This growth is limiting our resources and real estate options, and traditional urban growth models no longer meet our clients' needs. While we have traditionally built cities around a center with expanding urban rings, this model is no longer sustainable. Rather, sustainable water supplies must be incorporated into city plans to create a new smart city paradigm. I'd like to talk about a case study where this has been implemented. This is a picture of Singapore. It's a city-state that has really had to rethink their approach to drinking water. Historically, Singapore took its water from the Johor River from another country. But today, Singapore's water supplies look very different. They're diversified. They've built reservoirs to catch rainwater and also to return recycled water to supplement their potable water supplies. Additionally, they've constructed desalination plants when that rainfall does not meet their demands. Through this, they're able to sustain and grow their economy and their population, to such an extent that when Malaysia suffered a drought 2 years ago, they were able to supply water to Malaysia. Nationally, we face similar challenges to the rest of the world. Population migration to urban centers and changing climate impart stress on our water systems. In recent times, and probably most high profile, I know Texas has had issues too, but California is in the news. Sustained drought, severe water restrictions, and conservation mandated to protect public water supplies. This situation has generated a sustained focus on reuse. Highly publicized projects in major urban areas are focused on indirect and direct potable reuse. This is the treatment of wastewater and then blending that in with the public water supply. Indirect, sometimes that water is stored in a reservoir or sometimes underground in aquifers. Draft regulations are now out. They're in consultation. The basic approach is multiple barrier with this wastewater treatment. Similar steps have been taken here in Texas, but this is a very complicated set of regulations that are being developed in California. My understanding, Texas will look at these regulations and use them as a data point, but they will not adopt them wholesale. As we use new water sources such as wastewater, then more advanced technology will be employed to meet the Safe Drinking Water Act and state regulations. This is an example of membrane separation technology. This is a reverse osmosis type system. And we use technology such as UV in conjunction with hydrogen peroxide, sometimes ozone with hydrogen peroxide, to treat those microcontaminants that are dissolved and aren't removed by separation processes. These technologies are available today to treat this water. They're proven. However, they do add cost in terms of energy, and they're more complex to operate. This is a pie chart I took from the Texas State Management Plan. The population of Texas is forecast to approach 46 million people by 2060. That's an 82% increase from 2010. Texas is taking a very considered, managed approach to dealing with this population growth. It is going to be focused, as you know, on the major metropolitan areas in the state. The bulk of the investment is going to be on new reservoirs to impound, catch water. One example is the Lower Bodart Reservoir, North Texas, currently in permitting. Water conservation is a major focus, particularly on irrigation and municipal. Lesser extent, industrial. Industrial is not a big consumer of water. Reclaimed water is also part of the statewide plan, but it's not a major focus like it is in California. It's certainly a focus in cities such as El Paso, which is implementing a reuse program as we speak, using those advanced technologies that I showed you earlier. Right here in Houston, in the Houston area, the focus is on the transition from readily accessible, easy to treat groundwater to surface water. This screenshot is an early rendering of a surface water treatment plant that is now under design. And I really wanted to show this as the complexity and additional treatment processes needed for a surface water, taking water from a river, compared to a groundwater. The impacts that has on a utility is increased cost for maintaining those facilities, the capital investment to construct them, but also the operations and maintenance staff to keep putting high quality water out into supply. And this is causing a strain on some of the utilities in our industry. So one of the big issues facing the sector is retirement of highly qualified staff, and then replacing, retaining, and recruiting talent with other growing sectors of the economy that often pay better wages. So as we look to the future of our water supplies, it is indeed challenging. Urbanization and climate change impact our water supplies globally. However, with skillful management, non-traditional thinking, intelligent and appropriate use of technology, the issues can be resolved. A focus on resilience, diversification, and appropriate investment is necessary to sustain our supplies for future generations. Okay, that's how I wanted to end this introduction to water issues.